Hey everyone, so in this video we want to use this active switch concept and apply it to a nice little effect, and that is our Crag here that, as we know, is walking. Let's turn it into real time. There he is. We want him to fall apart while he is walking, and this creates a couple of problems, but we use Crag because it already has animation on it, so this is perfect for our case. Now the first thing is, let's build the main setup, and that is, of course, we use an assemble to pack every single piece of our Crag here. And as we can see, Crag is built of 67 different pieces. Then we put this into our RBD bullet solver, and let's see what happens. It falls down, so let's make sure that we activate the ground plane, and we can see, yeah, it falls apart as we expected. And of course we lost all the animation. So as we know, we can now say, hey, Mr. Crag, let's turn you into a deforming version. So to be clean, let's make sure we set all three attributes. We set active to 0, we set deforming to 1, and just to be safe, we set animated to 0 as well. So what we should see is that our Crag here, if we reset the simulation, there you go. When we press start, our Crag here is now moving. Now it's a bit slow because it has to read in the information every single frame, which makes it a bit slow, but you can see it's working now. Just to be, complete, let's try again the animated setting to 1 to see if that helps. And you will be able to see that no, it does not actually take the animation into account. And this is of course because we take an already existing animation and pack it afterwards, so the animation is not coming from kind of the points directly, but it's inside of the points, so to say. Just to repeat the concept, you could instead though animate our Crag here directly on the existing points. So for example, we could time shift the whole thing to only keep the first frame, and then we could use a transform to move our points from A to B, something like this, in 1 second. And this would actually be an animation because we take the points and move them directly. It's not that the animation is turned into points. And if we now look at the animated set to 1, everything to 0, we can see that this actually works. So this is an alternative, and depending how you animate your objects, this you would then need to use animated. But in our case, like it's often the case, the animation comes from outside and we pack them afterwards. So let's throw all this away and we stick with our deforming version. There you go. Which is much slower though. So what we want to do now is we want to let Crag, break apart by activating from the top down the pieces of our Crag. Now, of course, what comes to mind is what we used before in other contexts, in POPs, for example, for the sleeping function. We just create a group with a bounding box, and we can actually animate the bounding box directly in here. Let's make sure it's a point group, and let's call it activate. Let's call it activate group, just to not be too confusing. And then create a bounding box, and we can animate it from here to, let's say, 48 frames down here, and we can already see the problem. Our Crag is moving out of our box, and this is exactly what I wanted to talk about with you. Now, of course, one option could be we just make our box wider, something like this. And this will totally work in our case, even though it looks a bit weird for some reason, but doesn't matter. Maybe I have to adjust the, actually, let's not animate Z. There you go. So yeah, something like this. Now this is a bit tricky. In our case here, this will actually work because our Crag is walking in a straight line. But you can imagine with more complex animation, this doesn't really work well. Because if our Crag would be flying around, then we really have a problem activating, following with the activation group. That wouldn't be really a viable setup. But the thing is, keep in mind, all we care about here are actually attributes. And this is why I want to show you this technique. We can actually change the attributes on a static version of our Crag. So instead of going through the hassle of working with our animated version, we just create a time shift and take our first frame here where our Crag is not changing. And then we take our group here and let's make sure we have actually a starting situation. So the starting situation is deforming exactly. And then here in the static version of our Crag, now we have our animated group. And let's actually change a couple of settings, maybe something like this. Yeah, that looks good. And as you can see, it's much easier now to, define the areas that we want to activate. But what do we do with this? Well, since all we want to do is, of course, activate or switch to active, let's say the active attribute is 1 and all the other attributes are 0. And of course, let's make sure we only use our activate group. And let's have a look at the numbers. Oh, I just realized now I'm switching this to active in the group, but everything that is not in the group will have all 3 set to 0. And this is because our starting case, our deforming state, should be the starting also for our first frame, because then this is kind of the default. Active is set to 0, animate is 0, and deforming is 1. And only the points who move inside of the group will then be changed to active as here. Okay, so this works. So this is the setup you need. And now, as we said, all we care about are those attributes here that are changing over time. So why not just copy those back to our moving version of our Crag? Because the point numbers that are representing our Crag, because we packed all the pieces, are still there. They are the points, and they keep the same point number as the beginning. So all those points are just moving around. So of course what we can do is we can use a copy attribute or attribute copy to copy just the attributes from our static version to the moving version. Let's make sure that we actually copy active, deforming, and animated. There you go. And we should now see that even on our moving Crag, those numbers are changing. Yeah, we can see it now. So what this will result in is that we can change the state of each piece on a static version of our Crag, but we move this information back then to the moving version of Crag, and we can this way animate how it behaves without having to, care about the actual animation. And as we can see, the animation is a bit fast, so let's slow this down a little bit. Maybe something like this, and let's linearize the curves, and let's have a look at this again. And this way, even for complex animations, you can actually control how the attributes are changing over time, because you don't have to deal with the actual animation if you don't want to. And here you can see the result. Now, of course, this is still packed. So if we want to look at it in a nicer way, we simply unpack it before we render it. Or actually, we can even render it directly when it's packed as far as I know. But for the viewport, let's just unpack it. And then we have our textures and everything back. There we go. And then the whole thing looks like this. There you go. And now we have an animated version of Crag, and he falls apart while he's walking. That poor guy. So yeah, this is how you handle a case like that. We don't care where the attributes come from as long as they are on the right points. So an attribute copy can be useful to just move the attributes from somewhere else where dealing with our geometry is much simpler, like a static version of it. So I hope this is helpful. Thanks very much and see you later. Cheers.